Application of light as a wave. Reflection, refraction, diffraction, interference, and polarization. For reflection, reflection is a process in which when a wave reaches the interface between two different media, typically some of the wave will bounce back into the original medium. Note that according to the law of reflection, the angle of incidence is always equal to the angle of reflection. The angle of incidence is the angle at which light hits a reflecting surface, and the angle of reflection is the angle at which light bounces off a reflecting surface. As discussed, there are different types of reflection of light, one of which is the regular reflection, or also known as the specular reflection. This refers to a clear and sharp reflection. Regular reflection happens when the light ray hits a smooth plane surface. The other one is called the irregular or diffuse reflection. This one results into a rough finish and leads to a loss of brightness and also the quality of the reflection. Irregular reflection happens when the light ray hits a rough or curvy surface, causing the light ray to bounce into different locations.
To continue, some parts of light can be reflected, transmitted, or can be absorbed by the object. The amount of light that can be reflected, transmitted, or absorbed still depends on what type of material that the object is made of. Opaque objects mostly reflects the light, while transparent objects transmits the light, which we will call refraction of lights. So what is refraction of lights? In simple words, refraction is the bending of light from one medium to another. When the light hits the object obliquely, the light will bend at a specific angle, which we will call refraction of lights.
Diffraction refers to the various phenomena that occur when a wave encounters an obstacle or opening. It is defined as the bending of waves around the corners of an obstacle or through an aperture into the region of geometric shadow of the obstacle or aperture. Compactness. The process of diffraction is more vulnerable on compact discs. When light strikes the top of the CD, a portion of it is diffracted while the rest is reflected. On a compact disc, this is why we perceive a rainbow-like pattern. Ring of light around the source. If you look at any source of the light around you right now, you will notice that the light isn't transmitted directly in the forward direction. Instead, a later portion of the light energy is diffracted around the source. Due to the presence of dust and gaseous particles nearby, light diffractions occur.
So let's move on to the next topic. What is interference? Interference of wave is a phenomenon that happens when two waves meet as they travel along the same medium. There are two types of interference. First is constructive interference. What is a constructive interference? Constructive interference is a type of interference that occurs at any location along the medium where the two interfering waves have a displacement in the same direction. The second one is destructive interference. What is a destructive interference? Destructive interference is a type of interference that occurs at any location along the medium where the two interfering waves have a displacement in the opposite direction. Take note that although interference is a characteristic behavior of light, it is not solely an optical phenomenon. Interference also occurs between sound waves, as well as waves induced in a standing pool of water. A very concise and easy interference experiment can be performed at home using a sink full of water and 2 marbles.
Polarization, property of certain electromagnetic radiations in which direction and magnitude of the vibrating electric field relate in specified way. The most common method of polarization involves the use of Polaroid filter. Polaroid filters made up of limited materials that's capable of blocking one of the two planes of vibration of an electromagnetic wave. The use of filters is to look through and view objects. The filter does not distort the shape or dimensions of the object. It merely serves to produce a dimmer image of the object since one half of the light is blocked as it passes through the filter. Polarization has 3 types. Linear polarization. The electric field of light is limited to a single plane along the direction of propagation. Circular polarization, which there are 2 linear components in the electric field of light that are perpendicular to each other such that their amplitudes are equal. but the phase difference is pi over 2. And last, elliptical polarization, which the amplitude and phase difference between the two linear components are not equal.